what it is and how it's actually work. And what about this? So EtherChannel allow you to group the multiple physical interfaces into group which operates as a single logical interface. So it will group the whole interfaces, like right here. There's a several interfaces, and it will make it as a one single logical interface. It means that you can see these all are the several interfaces. It means that there are four, but logically it seems like the one single interface is working right here. If there is several interfaces working simultaneously, so as we know, if we connect the several interfaces in between the two switches, so where the always, as we know, the STP apply, right? So if there is a in the situation, this link will work, and about this link will going to be blocked because of STP. Okay, so what it do when it will going to change itself as one single interface which is logically work. Okay, so there's nothing worry about STP. Okay, there's nothing about the STP because STP is not going to apply in two nodes. Here the switch 1 and switch 2, in this situation the both will work, right, as a one single interface. So STP will not going to apply, or not going to be a problem for one single interface. It's treat better with one single interface. Nothing gonna happen bad with it. Okay, yeah, this is what now initially we have need to know. Okay, so what about this? Why we have the need to enhance or add multiple links to it. So as you can see, at access switch 1, there's just several in devices are connected to it. It means that at switch 1, which is access switch interface, or the high bandwidth. Okay, about this distribution switch 1, which have the low bandwidth. So to enhance, if there's a one single interface in that scenario that I'm talking about, if there's a one single interface is working right here without these. Okay, so it seems there's a low bandwidth, and what about this is a high bandwidth. Okay, this is all the high bandwidth because the whole data is going to pass through this in one single interface, which is cause the problem, which can cause the problem right here. So for that reason we do use the multiple links, and we band these all links or bundle these all links and make this all at a one single interface where the STP is not going to be make any problem to it. So it seems a one single interface and logically flow. The whole thing is based on flow. Okay, now what about this all it's talking about? Okay, now a layer 2 EtherChannel is a group of switch ports which operates as a single interface. It's talking about the layer 2 EtherChannel is a group of the switch ports right here. This is the layer 2 EtherChannel. Okay, remember this. This is the scenario. Okay, which is L2. The switches are L2. But if there is a L3 switch, so we will going to understand this situation too, which is talking about in this which is based on the IP addresses. So as we know, at layer 3 switches we do configure with the IP addresses thing, right? So which is right here too. There's nothing about something which is going to be stuck to it. Now, so what about this which is right here? And this is nothing very special situation about this, but let's see what about the next thing as I discussed over here, which is right here. So when the bandwidth is bandwidth of the interfaces connected to the end host is greater than the bandwidth of the connection to the distribution switch, is called the oversubscription. The situation like, but here is if there is the high bandwidth, if there is a high bandwidth, and here's the low bandwidth with one single interface which is working over here. So this situation we call the oversubscription. This is called the oversubscription. Okay, the situation called the oversubscription with the high bandwidth. To prevent this situation, this problem, we do use EtherChannel. Okay, now if you connect two switches together with the multiple links, all expect one will disable by spanning tree protocol. Green light versus the orange light above on the switch one right here, as I was talking about right here. That's the same thing as it's talking about at this point. But the thing that we have to understand is the STP will not going to apply at one single interface. Okay, it's a prevent the loop where the loop are. So if there's a switch one is going to transmit the data through this interface, expect this interface it will going to be broadcasted the same frame sequence of frames to these all three interfaces. So it means that it's possible, there's a possible to create the loops if we will going to be bundle, if we to bundle these all interface, and logically it seems at the one single interface. So there's nothing about which can cause the STP, okay, which can stop because of STP. Okay, now why, if all of access switch one, okay, the interfaces are the forwarding, the layer 2 loops would form between switch 1 and distribution switch, leading the broadcast storm band. This is what I'm talking about. If there's nothing, if there's an STP will not apply, so it would create the broadcast storm. But if we will bundle these all and make the one single logical link, so STP will seems like it will understand it's a one single interface, there's nothing about to worry about the storm or broadcast storm to it. Okay, other links will unused unless the active link will fail. In this case, one of the inactive link will start forwarding. This is the situations we usually do when we use the STP. Okay, now what about this situation that I'm talking about, which is right here the link. Okay, so an ether channel is a network topology diagram. It is represented like this: the circle around the multiple connection which representing right here the one single logical link. Ether channel groups the multiple channels together to act as a single interface. This is the important thing that's talking about, and this is the logic behind this whole thing. The single interface, it would make the single interface, so all interfaces. The STP will treat this group as a single interface. There's two main points that you have to consider for now. Okay, well, now all interface green. Yeah, when we bundle and these also all are making sense to each other and it seems as one single interface, so there's nothing, all are green. It means that they will pass the problem, or they will pass or bypass the problem with the STP. The traffic using EtherChannel will be load balancing among these physical interfaces in the group. What does it mean? Okay, let me just take this all in a different situation. Okay, I will take this one. Okay, it would help you to understand this image if I will drop it over now. So what's talking about the traffic? Okay, so this is a PC1 PC2 based on. So now an algorithm is used to determine which traffic will use which physical interface. Okay, more detail later, but the more detailed thing that we are going to understand when we will prepare the CCI, or when we have need to go in depth how to actually do the region behind this all. Okay, so for now it's a basic thing that we are covering right here, but not a basic as per the CCI, not for CCNA or CCNP. Okay, there's a some similar terms that we use in the context of ether channel. So right here, as you can see, port channel and lag, that we call link aggregation group. Okay, so lag is also known as a ether channel, and port channel are also be known as a ether channel too. Okay, so be familiar with these all terms. Okay, with the port channel and the LAC, link aggregation link aggregation group. Okay, now, okay, how does an ether channel load balance? Yeah, this is the highly substantial essential thing about this is the speciality about the Ethernet channel. This is the ability about the Ethernet channel, how it will balance the loads in context of traffic. Like, so here it is, the Ethernet channel load balance based on the flows. A flow is a communication between two nodes in a network. Right here, there's two nodes and communication between two nodes. Right here, the PC1 is going to the server or switch 1, the printer 1, and PC2 is also going for the printer 1. So you have to just think about this situation right here. Frame in the same flow will be forwarded using the same physical interface. Yeah, so it's talking about the flow forwarding using the same interface right here, as you can see, but it's a different situation. That this is correct, it's absolutely correct. Okay, but here it's absolutely correct, but here's this is talking about it's a based on the scenario. If the frames in the same flow where the forwarded using different physical interfaces, some frames may arrive at the destination out of order or out of sequence, which can cause problem. Yeah, so suppose that this interface which is this PC2 frames is going for, some of them is going in another, like it will go, some of the frames will go from the this interface, some of will go this, and some of will go this way. So it could cause it could make the problem when it will arrive to the destination. So it could become the problem, because out of these all are going in out of order. Okay, so they have to choose one single interface to go in a flow. This is what is talking about, to balance the load. Okay, especially we're going to use the interfaces for each frame. Okay, so for the frame for the PC1 frames, it will go this way. The PC2 frame, it will go this way. It means that the overall the selection of the interfaces to transmit the frame will go only through the one interface to balance the load. Okay, you can change the input, use the interface selection calculation. So yeah, as per our need or as per our requirement, we can do this whole thing, like the port selection, or like for which port it will go right here. So you can change the input used in the same in the interface selection, so calculation that we can do for the flows, which interface it will choose. So here it is, the 6 ways to do this all. Okay, so the first thing is a source MAC address. The second, destination MAC address. Source and destination MAC addresses, source IP address. There's two things mainly, the MAC address is based and IP address is based. So we most of the way we go with the IP address is based, because I will tell you the reason after one scenario, which is further you will going to see right here, which is a highly essential in this all context that I think and that I consider right here. It's probably you will going to see the all the uses, but in the real and modern networks you will going to see this all the IP addresses for the source one, for source and destination based, or last three will going to frequently you will going to see. Okay, now how to see the configuration for the load balancing method. Yeah, here it is. Let me just put my way right here. Okay, so now. Okay, now we can so as switch 1. So before doing any configuration and context upload balancing, first we have to check. Okay, so first we will go with the command. So EtherChannel load balance, remember that. Okay, EtherChannel load balance. So it will show the load balancing configuration, which is, as I told, the source and destination IP right here, the last one. So here it is, the last one. Okay, so the source and destination, the method it's chosen right here. Okay, so the channel load balancing address is used in per protocol. Yeah, it's totally based on IP, IPv4, IPv6 based, or destination MAC addresses. When at the non-IP, it means that it will definitely going to be use the MAC addresses based selection. And IPv4, the destination IP is going to be choose. When we talk about the IP based, so definitely that will the source and destination which is based on the IP addresses. And the IPv4, both are the versions, so it means that specifically is work on the IP. So whatever the IPs are, the IPv4 or IPv6. Okay, now okay, now what about this one? How to change the load balancing method? So if I want to change the load balancing method, what I have to do is, so specifically I'm doing in a switch 1, which is the access switch. The COM table, I have to go in global configuration mode. In global configuration mode, I have to do these all the changes in a context of changing this, the port channel, specifically the port channel, the term that you can see right here, the port channel. The port, when you do configuration, you have to just use right here the port channel. Okay, when we have to show, so that we use the EtherChannel in this context to show EtherChannel, port channel load balance when we do edit or any changes that we make, any commit that we do. Now, so okay, so the thing that you have to learn over here, this is the thing like port channel. This is right here. Okay, this is that you have to understand and do. So EtherChannel is also command to consider or take a look at over here how it's actually work in real. Okay, as I changed to source destination MAC from what, from source destination IP to source destination MAC. From source destination MAC, no, the source destination IP to source destination MAC, that we made changes. Okay, now if I want to see how many ways we can do in real, the way to do. Okay, so we have to put the end of that the method as there is a 6 which is right here, the destination IP, the destination MAC, the source and source and destination MAC with the IP and MAC, the IP source MAC right here. These all are given as we have seen before. How to configure the layer 2 and layer 3 EtherChannel. So let's see how we can configure the layer 2 and layer 3 EtherChannel. There is a 3 method of EtherChannel configuration on Cisco switches. So the PAgP, remember this is specifically that we do use for Cisco switches. Okay, it's all over because it's a proprietary protocol. Okay, It's a proprietary protocol, and it's a create dynamically. If I want to just create without bothering, like it's automatically going to be do, like it's as we have seen in a selection of data trunking, when we do configuration of trunking based, which is based on DTP. So there was the two things, like the auto and desirable. Okay, so there was a two thing that was based on, okay, is dynamically changed. Okay, so let me just okay, so what's it really talking about when we call the PAgP, the port aggregation protocol, the Cisco proprietary protocol, dynamically negotiate the creation, maintenance of the EtherChannel. So it means that we have right here the DTP does not does for the trunks. DTP does for the trunk the same thing, the same functionality that we see with the EtherChannel in the context of doing with the PAgP, which is Cisco based, and it's a proprietary. It means that it's work in the Cisco devices. What about LACP, link aggregation protocol, control protocol? The link aggregation control protocol is industrial standard protocol IEEE 802.3 AD. Remember this, the point right here. This is the essential thing right here that you need to know. Let's dynamically negotiate the creation, maintenance of this EtherChannel, like it. Yeah, it's the same thing. It's actually do, but the terms that we use with the PAgP and the LACP, both are different. For LACP we use the different terms, and it's a like active and passive. It's based on the active and passive in the LACP, but in PAgP it's based on auto and dynamic, auto and desirable. What about the static EtherChannel? Protocol isn't used to determine if an EtherChannel should be formed. Okay, it means that it's going to be fully based on its individual, fully based on static. It will not going to be considered for each other. Okay, so interfaces are statically configured to form an EtherChannel. Let me just have some drink. Okay, now what's talking about, up to 8 interfaces can be formed into single EtherChannel when we talk about LACP. So it will goes up to 18, oh sorry, it goes up to 16, but 8 will actively work and 8 will work standby mode. Okay, 8 will work in active mode, but 8 will work in standby mode, waiting for an active interface to fail. The 8 apart from all 8 active interfaces, that's all 8 will work as a backup. Okay, what about the PAgP configuration? Let's see what about this all. Now we can continue. Okay, so the PAgP configuration, we will going to cover with the range 0 to 3, the interfaces, where we are going to configure with the PAgP. So as you can see right here, okay, now you can see PAgP is only go with the auto and desirable. Okay, this is auto and desirable, both will work with the PAgP. What about this, which is only for on? And what about this? This is for the LACP. Okay, this is for the LACP. The both will work for LACP and these both will work for PAgP. What about this? This is for EtherChannel only. Enable the EtherChannel only. Right. Okay. So as you can see, the access switch, the configuration with the range command, channel group 1, number, channel group number, mode desirable. Okay, we have to change or choose the name. Okay, now, so what about this? What does mean of this? So when the both interfaces, the both end of these interfaces, if there's an auto at the switch, at one of the port auto and one of the port is auto, no EtherChannel will work over here, no EtherChannel will form, or no EtherChannel will work over here. It should one of the desirable should be there to work this. Okay, if there is a desirable, there's nothing about. So desirable auto will work with the channel. Desirable will also work with when we see this situation. So it will goes with the channel. It's a similar thing, you know, that we have done in DTP. Okay, so this is what these all are given about this context. PAgP negotiation to form EtherChannel, yeah, that we have done. Okay, so AWS1, actually this is the access switch 1 configuration with the range, channel group which is 1, mode desirable, that we have done. Okay, now, okay, creation a port channel interface, port channel 1. This is what that we have to understand right here about the port channel, the term port channel. Okay, so for that reason I will drag and drop over here about this. Yeah, so shows up in the interface as the port channel right here, where, as you can see right here, the port channel 1. So is up, the status both have up. Okay, the protocol, it means that it's talking about this node to this node, it's next to it. Okay, it's up, both can sense if it's working this situation as an interface, so it's talking about the next to it. There's no relation in between this protocol that I'm talking about, but that you have to just consider about this, what are the reason behind this, because you will going to see the same thing again and again. Okay, so the channel group number has matched for the member interfaces on the same switches. Okay, yeah, so the channel group, it's actually it should be different, you know. Here it is, like channel group 1 on the switch can form a EtherChannel with the channel group 2 on the distribution switch. It means that if there is a switch 1 which is access, there is a switch 2 which is a distribution, so the channel that it will work over here, that will a channel group 1 and the channel group 2. Group 1 or group 2 both can't be same. Okay, Now LACP configuration, specifically about this. So LACP configuration, the note is here, the active passive, as I told, the passive and active is given over here. If there's both are passive, no Ethernet channel will form. If there's active and passive, so yeah, it means that the active should be there in both situations. Whatever the situation is, the active, if there's active, so Ether channel will form or it will work. LACP negotiations for form and Ether channel. Okay, I was talking about the negotiation, which is the same, but the terms are different. Okay, it doesn't have a match the group. Yeah, the same thing with that one and this one too. Okay, there's nothing about special, but both should be different right here. 1, 2. The static Ether channel configuration. The node 1 is only available mode with the static, so it means that the ones should be there. Okay, and whatever it means that the only mode should be there in this, not in this situation, but let me just take it from here to here and zoom it. So yeah, is there something about this? Okay, this is a different thing. Okay, so on mode only work with the no mode. Okay, on mode here, on mode here. It means that that's only thing which should be similar. Mode should be similar. There's nothing about if there's a right here the active and passive that will also form, but with this one that we call the static Ether channel configuration, that should be on mode and on mode. Then after it will form. Other than this, nothing will happen. It does not work. Okay, two options: the LACP protocol and LAGP or PAgP protocol. Above shown a protocol mismatch error because LACP does not support desirable only PAgP. It means that if you are try to create the configuration, okay, let me just take it. Okay, if I'm setting the if we have you will always initially you will see the protocol channel, and then you are putting the question mark, so you will see there is a two protocol mode, the LACP and PAgP for Cisco and LACP for all standards. But if you are choosing the LACP, it means that you are going to use the terms in the case of selection or in a formation. So you will see with the LACP that will active and the passive. Okay, so active and passive. So it means that you have to just think over here in this all context right here. So active and the passive right here. Okay, so the same thing that's based on the LACP. So if I want to form the LACP, I have to use, but this is the mistake that he done, which is right here. The mistake, as you can see, it's a desirable. With LACP, it's can't desirable. It should be active or passive. So here is the mismatch. So if I will put the mode active, it will create the port channel. The creating the port channel interface, the port channel 1. It means that these all are that should be same, then it will work. Okay, now after configuring the Ethernet channel mode, what is next? Okay, so once we have configured with the perfect or with the similar, not mismatches that we have done before. Finally we did done it LACP with the active mode. So it will create the port channel 1. Okay, so switch port trunk encapsulation dot this is the formation that we do. This is the thing that we do when we create the trunking. So the mode trunk, so interface is trunk. So you will see the trunking and the native VLAN right here. These are all the things which is a basic thing that you have seen before. There's nothing specialty about this or something that is quite relevant to it that we can discuss over here to it. Now we can consider at this one. So once we have done, so what you will see is the port channel which is right here, which is created. So when we do configuration in this context, the port context mode trunk, so there's all changes that you will make, it will apply all each and every interfaces right here. Okay, it goes up to, it goes up to switch interface 0 to 3. Okay, it goes up to 0 / 3. In G00 or G03, whatever the interface, but for the switches we'll always going to say in between the switches the gigabit, but in between the switch and end host the EtherChannel will work. It means that is automatically applied. Okay, so as you can see is the configuration, so it's done. So it's showing the this thing configuration that you can see. Okay, as a substantial thing. Now the physical interfaces from G00 to G03 were auto configured by the port channel configuration. Important notes about the EtherChannel: the configuration, the members interfaces must have matching the configuration, the same duplex, full half duplex, whatever the duplex is, that should be same, right? Okay, the same speed, the same switch port mode, access or trunk, the same VLANs, native VLAN or trunking interfaces. If an interface's configuration do not match the others. Okay. Let me just no. So if the interface is configured, do not match the others, okay, it will be excluded from the Ethernet channel. Yeah, that should be same. Each thing should be aligning to each other. Nothing would be different. So it will accept and it will work. If it's not matching to each other, definitely that will exclude it from the EtherChannel. Or we can, if I want to make changes deliberately, if I want to something that I want to make change or disable, that I can. So EtherChannel summary. So what about this? The EtherChannel summary: D for down, P for bundled, okay, P for the bundled port channel, okay, D for down, I for stand on, S for suspended, H for hot standby, LACP only. It will work with LACP only, hot standby. Okay, because there is a 16, right? So it will actively work and it will work as a standby. This is what it's talking about. R for router, the layer 3, S for switch, the layer 2. And use the R1, RU and SU that you will going to see. RU, SU, RU, the switch in use, the router in use. Okay, F for failed, and M not in use, minimum link not met. Okay, these all are given you. Unsuitable, waiting to be aggregated, D default port, A found by auto LAG, link aggregation group. Okay, number of the channel group in the switch one, the number of aggregation one, link aggregation lag is link okay, not a protocol, it's a group. Okay, now we can remove this from here. Now note the information at the bottom. SU means S for the switches, which is the layer 2, U for in use. Okay, that I have done before, as we have discussed before. The protocol, what protocol the ether channel is used in, it's a case LACP, the port. Okay, the list of interfaces in the channel, the P bundle, the port channel. Okay, now so what about other flags in users? Let's see if there is a DDD which are down, so SD, sorry, okay, that means that these all are given about the uses that all are as per the scenario based thing, the changes that we do make, that's all are given right here. The D for down, S for suspended, SU, it means that SU the switch, which is the layer 2, U for in use, S for suspended. This is the mean of this. Changing one of the member interfaces using the switch port mode access has made it the different than on the other member, so it can so it now appearing as suspended. Yeah, there's mean of this, it is given over here. This is scenario, right? Whatever the changes that we make, that you can see with the interfaces below it, it's just given over here. Yeah, it will you will understand whenever you do that access that lab. So yeah, so ether channel, the port channel, given the port, number of ports and the modes, the protocol that they are using right here. So spanning tree will show the single ether channel, the port interface. Yeah, the single interface, this is talking about the interface tree. So which channel is talking about, and what is what the thing about this channel, like, so spanning tree. So as you can see, the priority number, the type, that are given. So now okay, so the root page ID has the thing that we have to consider. This is the interface, which is the P01, which is the Ethernet. It's already done, and the it's already done the ether channel formation, or that's all protocol thing that it's done. So it formed at one single logical link. So it means that whenever you will going to see a large number of interfaces in a one single logical link, so it will seem you always in this form, like the P01. which is right here that you can see. If I will drop it over here, this PO01, which is this interface. Okay, now how to configure the layer 3 ether channel from the clean configuration. Okay, so this is about the layer 3 switch. What about this and how we can configure this all? Okay, so this is the thing that we usually do. First, to create the ether channel. Once it's created with the no switch port, it will going to actively work with the layer 3 abilities. With that, it will work as per the IP addresses is the best thing. So no IP address, so interface the gigabit Ethernet, no switch port, the same thing is going to apply on each and every interfaces right here. The switch, the interface G0, 2, 3, 1, all are there. No switch port and no IP interface. Where do we configure the IP address? Directly on the port interface. So what it will do, the interface which is right here, it means that we have to think these all interfaces in a one single interface. So the configuration that whatever we do, it's based on the one single logical link. Not all physical links are not given, but we have to now think right here as a one single logical link. Whatever the XSM looks in physically the large number of interfaces, but we have to think logically, and configuration that we have to do logically. The topology that you see, the physical, which is not in real, the logical topology could be different. So this is what it's talking about. Okay, so where we do configuration, IP address, yeah. Now over here, are you this is what is talking about the router, which is the L3 in use, the router in use, the L3 in use. This is the indicator of this. Now the configuration that you have done for this, the IP address you assign to that interface to enhance the bandwidth. So if I will say the whole thing in a few words, like in conclusion, okay, so what's happening is, this is the layer 3 switch. Okay, this is the layer 3 switch. So the thing is, it's a right now working as a router, and this is also working as a router. The configuration that we do with the router, which IP address is based right here, as you can see. Okay, this is the G.1 and this is the 0.2. It means that it's a 10.0.0.1, it's a 10.0.0.2. okay, so as we usually do the configuration in respect of the router with the one single IP address with both end, it will do. So we have to treat this interface as a one single link. Instead of this, you have to assume it's a one single link, not four. So it means that they have to link in between both IP addresses. Get it? Now, okay, command learns in this chapter, that is, okay, so this is all the command: port, channel, load balance, the mode that you can choose, right? There's 6 mode. the configuration, the channel load balancing method in the switches. The switch, so it's a channel load balance. So when we call the switches, so in this context the ether channel, but when we call the ports, so it means that it's making the configuration. Display information about the load balancing. So yeah, here it is. This active, auto, active, passive, on, these all are the modes. Desirable, auto, active, passive, on. Configuration interfaces to be part of an ether channel. So ether channel summary. So you will see these all the indicators that you can find well when you go with this command. Display a summary of the ether channel in a switch. So if I will drop it over here like this, display information about the virtual port channel interface on a switch. Okay. Now here's the table. There you can understand about this part. I think you can mind yourself about this, how you will going to be think about active, passive is always auto, desirable is always for the PAgP, and for this LACP, passive and active, auto and desirable. There's nothing about this, but on always for each. Okay. Okay, so this is all about this. I hope you understand well, and you can repeat this thing again and again to make your understanding better. This is what is, I don't know how much time it is taking for you, but for this chapter I would say frequently if you are doing so it will take less. This is the thing that I understand. I'm doing to this all the way, but yeah, it's also a way of enhance your ability of explanation. Is also work in this way. So yeah, you can do this way whatever I'm doing too.